Aging population is a pressing issue faced by the Japanese society and the world alike. In the year 2010, an OECD report found that Japan ranks top amongst nations facing aging population. Japan will continue to take lead in the current trend by 2050, according to estimates. Labor shortage in caregiving sectors further exacerbates the situation. Artificial caregivers still have a long way to go before reaching human-level performance. One way to improve is by making AI as perceptive as human minds. Human minds have the ability to perceive incomplete data and make inference about the entirety. This follows that AI should be made capable of imagination. In real life, seeing things yet to be seen means a great deal to decision-making. For instance, elderly fall prevention. With the help of imagination, seeing a limping elderly from behind can be interpreted as potential fall hazard, which can be proactively intervened. In what follows, we will demonstrate human activity recognition inside agents' own imaginations. In this part of the video, we show the functional elements that underlie the agent's ability to imagine its own surroundings given incomplete contextual cues. First, as displayed on the right side of the screen, we created a room filled with static objects in a physics simulation. Then, we expose our agent to this environment for a limited amount of time, hoping for it to draw a generalized picture of the room given incomplete exposure. Let's see how this is done. This is our agent. We let it move around the room and take some photos. These photos, along with the positions and orientations with which they were taken, create context for imaginations. It goes without saying, these contexts must be connected in a meaningful way. After all, these photos are about one particular room. Technically, we make the agent learn a representation of each contextual cue that preserves compositionality. This means independent representations can be fused to create coherent and integrated meaning. A variational autoencoder, conditioned on the integrated representation, called Generative Query Network, takes an arbitrary query as input, and samples an output. A query is a position-orientation pair, unencountered by the agent during its exposure to the environment. If we dial the query, one can see on the right side of the screen, the agent samples images as if it's navigating in its own virtual reality. We close this part by demonstrating a free movement inside imaginations. A comparison is made against reality.
Having demonstrated an elementary version of the making of imagination using the Generative Query Network, naturally one could follow with the question: in addition to imagining a static scene, can we imagine something moving or carrying out certain actions which may or may not be happening in reality? The answer is, of course, yes. And as it turns out, our decision, and the course of actions that follows, is quite often overshadowed by this sort of information we pulled from our own imaginations. Next, we will give a practical example of imagination that encompasses a dynamic environment along with a human actor. This example entails an obvious scenario, which takes place when we observe someone else's activity from an occluded or less informative viewpoint. Let us take a look at the following activities as seen from behind a person. Can you tell what the person is doing? Is he handling a knife? Or is he cooking a meal? In fact, he may very well be making a cup of tea. Or any of these possibilities. Evidently, these activities appear to have some differences. Yet the differences are not large enough to derive a definite judgment. Imagine what an easy task this would be, if only one could assume some vantage points. This is where imagination kicks in. In other words, we use imaginations as a strategy to overcome uncertainties in decision-making. Before performing any actions, the agent is able to draw a number of hypothetical viewpoints, and evaluate which of them leads to a better understanding of human actions. Say, if the agent were to assume a 6 o'clock position to the human actor, the agent's imagination might look like this. As we already know, this is not an informative position, therefore, the agent lacks confidence. Alternatively, if the agent were to imagine the human from the 2 o'clock position, he can be much more confident in disambiguating the types of activities performed by the human. In summary, the overall procedure follows these steps. 1. Condition the Generative Query Network, or GQN for short, on the partially observed scene and human actor. 2. Pass any query vectors to the network and sample the corresponding imaginations. And 3. Evaluate the confidence in recognizing human activity by using a combination of keypoint detector and classifier. These steps are repeated until a number of queries are collected, and the agent is sufficiently confident about its target position. This is exactly the timing at which the agent's action is actually carried out. Finally, we will demonstrate some preliminary results of imagined human activity.